Hey guys, today we're going to talk about common denominators, and that's what we really need to do first whenever we are going to add or subtract fractions or mixed numbers. So really that means, we talked about in class, you can't add 6 to tenths. So you need to rename them. Just like you can't add apples to oranges, you need to rename them fruit. So we're going to rename sixths and tenths in order to come up with a common denominator or way of doing this. Let's start with this problem though, because I think it's kind of a good one to start with. So if I have the fraction 1/4 and 3/5, first thing I want to do, looking at the denominators, is say, hey, can I change a 4 into a 5? Or is 5 a multiple of 4? Is 4 times something 5? And the answer is no. So then the next thing that I want to do, since that doesn't work, usually my second choice would be to say, okay, I'm just going to do 4 times 5, and I'm going to change them both into 20ths. And then that just becomes the whole thing that we worked on with equivalent fractions. 5 times 4 is 20, so 3 times 4 is 12. So we just renamed 3/5 12/20ths. And then I go over here, and 4 times 5 is 20. So 1 times 5 is 5. So I rename 1/4 5/20ths. I essentially am done with these two things, so we can kind of get those out of our brain. So now we really would just be adding those two things together. And we know that whenever we add, our purpose was to find the same denominator, the common denominator. So we just take that across. We don't add those together, but we do add together the numerators, so our answer would be 17/20ths. Now, sometimes we get lucky and we only have to do half as much work. So that's the case for this one, 3/4 plus 7/8. I'm going to look at this and say, hey, can I change a 4 into an 8? Is 8 a multiple of 4? Or can I do 4 times something equals 8? And yay, I can. So that means I can leave this guy alone. He does not need to be changed at all. I'm just going to change 3/4 to so many eighths. And how about right now, if you're watching this video, why don't you write 4/8, just for fun, write 4/8. Right beside your name. So in the upper right-hand corner of the page, write 4/8. Okay, so in this case, I'm going to do 4 times 2 is 8. And whatever you do the bottom, you got to do the top. So 3/4 is the same as 6/8. So now I'm done with that. I just renamed it into an equivalent fraction that works, that works for me. And now, how many total eighths do I have? Well, 6 plus 7 is 13. And we know that 13/8 is just a division problem, 13 divided by 8, which is 1, and 5 leftover eighths. So the answer to that one is 1 5/8. Next one. Sometimes we might get a fraction like this, 2/5, not times, goodness gracious, plus 8/15. And we look at that and we go, oh, can I change a 5 into a 15? I sure can. So I'm going to make this a 15. That means I leave this guy alone. So if I want, I can just move him down here. 5 times 3. So 2 times 3 is 6. So we just traded in 2/5 for 6/15. And when we add this up, we get 14/15. One more example for you today. So I'm looking at 2/6 plus 3/10, and I first asked myself, can I change a 6 into a 10? Is 6 times something 10? And the answer is no. So then the next thing I might want to do is 6 times 10 to come up with a denominator of 60. But in my head, I'm like, man, 60 is pretty big denominator. So is there any way that I could make it simpler? And really, we can use this strategy of simplifying this first. So 2/6, remember when we simplify, we're saying what can we divide them both by? And they are both even, so we can divide them both by 2. So 2/6 is really the same as 1/3. 1/3 is the simplified version of 2/6. So now I can add 1/3 plus 3/10. Now, I still cannot change a 3 into a 10. 3 times nothing is 10. But now, if I do 3 times 10 and I change them both to 30ths, that's a lot easier number. So I'm going to do 10 times 3, and whatever you do the bottom, you got to do the top. So 3 times 3 is 9. We replaced 3/10 with 9/30. 3 times 10, so 1 times 10 is 10. We're replacing 1/3 with 10/30, and we're now adding those. Our answer is 19/30. See you next time.